11, and 12. So at number 10, what was the average for this pick 4 game?
Negative 41 cents.
Negative 41 cents, are we agreeing? Negative 41 cents for number 10. So what does that mean? You walk up with $1 to play the game. You lose 41 cents of that dollar. So why not just walk up and give them 41 cents and walk away? Because that's what's going to happen on average. You're going to lose, if you're looking at the actual distribution, you are going to lose 74% of the time. That's what that says, right? If you're only going to get 0 or 1 74% of the time, that means you're losing 74% of the time. These guys back here figured out, on average, you're going to match 1.3 numbers out of 4. 1.3 numbers out of 4. They only pay you if you match 2 or more. So on average, you're always going to lose. And that's what you just proved numerically. You guys proved on average you're going to lose, but doing it with the dollar amounts proves on average how much you're going to lose. Thank you. Now the beauty of this was these kids were paying attention to the payouts. This is so genius. They doubled the payouts for this 1 month stretch. And what's interesting is they still lost 74% of the time. They didn't change the problem. Remember what Rory said about the actuaries? They have no say about this. The numbers come out of those things the same way they always have. You're still going to lose 74% of the time. But they doubled the payouts. What was the new average?
19 cents.
Positive 19 cents. Which means you walk up to the little cashier with your dollar and you say, oh, you know what? Just give me 19 cents. I'm going to keep my dollar. Think of one bank account that pays you 19% interest. None. None do. Not over a course of a month. So these kids were geniuses. They figured this out. Actually, I was saying they're geniuses. They're statistics students. The same thing you guys could have done with this information. Watch Keno. The next time you walk into a bar, look at the Keno rules. Have anything changed? If it hasn't changed, don't bother. Because if it hasn't changed, the poor drunk guy that thought he could apply it to bet 4, which didn't have the same payouts, he lost all his money. But the idea is these kids don't have to care that they're going to lose 74% of the time. The times they win make up for those losses. So all they did was they borrowed a bunch of money, bought a bunch of tickets, $5 at a time. Look at the number, look at the amount of money they made. They never once told me how much they made, but I extrapolated based on how much they told me they played. That's it right there. Isn't that ridiculous? That's 4 days worth of work. That's 4 days of work, 4 Wednesdays in whatever month that was, February or March, whatever month that was. Isn't that insane? Because it doesn't matter. You're going to make 20 cents on average on every ticket, even if you lose 3/4 of the time. The amount you earn, the amount you win, makes up for the losses. Lauren, go ahead.
So I'm assuming that every casino or place has a different payout. So how would you go about finding that so that you could do the math before
Quiz
you
next
go
week.
in?
Quiz next week.
Oh.
You have to know how to measure the probabilities, which can totally be done. FYI, on this quiz you might have noticed, and I'll get these quizzes back to you on Tuesday, hopefully. If Amber doesn't get them great, I'll get it back to you as soon as I can. I offer some extra credit on this one. You may have noticed it. I don't know if you noticed it or not. At the top of page 2, I put the probability of getting each event, and there's a little tiny footnote. I'm one of the few people left on earth that still uses footnotes. I apologize. If you look at that footnote, it says, if you figure out how I got these numbers, I'll give you some extra credit points. It's something called the hypergeometric distribution, which is a freaking fantastic name, too. These distributions we're studying right now, this one right here is called the binomial. We're going to get into that a lot more on Tuesday. Okay? The one we studied a couple days ago was called the uniform, the single die rule. It's called a uniform distribution. This one's called a hypergeometric distribution. I've got a quiz planned for a couple down the road, which is called the geometric distribution. Remember the coin flips? Remember the coin flips? That was geometric, because every time you flip a coin, we lose half the people in the class. That's geometric. All these things have these freaking awesome names. This particular one is called the hypergeometric. If you want to do some Googling research on that, we'll give you some extra credit points. So to answer the question, it was Lauren's question, right? You have to know which distribution the games follow. If you ever want to know, just email me. We'll figure it out together.
But aren't they? Yeah, but
they're fixed. As soon as you know what they're using to generate the randomness, you know what the distribution is.
a good payout you're talking about.
What's that?
They tell you, right?
Well, they either tell you or you can figure it out. If they're telling you they're using a deck of cards, it's hypergeometric because they're pulling a card and not putting it back
For
in.
instance, like if you play like the Oregon Lottery, like
Chances are, yeah.
Powerball, for example, yeah.
Or like the whatever you put those like dollars into like, the little cage.
Machine.
Like a scratch it ticket, you mean?
No, like the machines.
Oh, like it should have wins. Like that's binomial. That's binomial because you've got the wheels that are spinning. That's binomial. You could get like cherries across and you win the jackpot.
But if I was sitting down what's the payout? Would they tell me?
I have a craps quiz on Q2 for you guys. No, well, yes, they do, and many times the tables themselves have payouts on them.
Okay, then I go home, do my math, and come back and decide if I want to play or not.
Well, you can decide you want to play, but don't decide if you want to play based on the payout because you're never going to play.
Well, no, but what's the probability? I mean,
Good.
I mean,
What's the
probability?
what's the best game to lose my money the slowest?
Yeah, that's what I was talking about.
Does that make sense?
Yeah.
But craps, I can tell you that right now, it's craps.
Okay.
Line bet on craps. Wait, no. Not a line bet. Don't pass bet on craps will lose you your money the slowest. That's betting against the roller. So here's a quick introduction to craps. Throw a pair of dice. If you roll a 7 or 11, you win right then. They pay you $1 back and you're done. If you roll snake eyes, 3 or 12, you crap out, you lose your ante. If you roll anything else, you keep rolling until you roll that sum again. So if you roll a 4, you got to keep rolling until you roll a 4. If you roll a 7 before that 4, you crap out. It's not called crapping out, it's called something else, I forget what it's called. That's craps. The chance of winning on a pass bet, which is the roller betting on himself or herself, is about 49.3%. Just below 50-50. Just below 50. And the reason it's just below is because of that convoluted thing I just described to you. If you bet against the roller, it's something like 49.4 or 49.5%. It's a little bit better odds betting against the roller, but it's still below 50-50. Which means they're making money on every one of those people. Just a little bit here, a little bit here, a little bit here, a little bit here. It's like Office Space. All the pennies that get rounded off just go into the bank account. That's what craps is for the casinos. Cool? I got some quizzes planned. Now that the damn network's back up, I can actually make them for you guys. Yes. This is probably the most important stuff we've learned all term, honestly. And we're going to keep with it with your permission, because I think it's that important.
I did it.
Okay? Yeah, make a pile up here. That's perfect, Taryn.
L2.
Be well, friends. Have a great weekend. Please do. This counts against you.